All right, let's look at an example where we need to calculate percentile rank and kth percentiles from an ungrouped frequency table using the context of student sleep. So in this example, 50 statistics students were asked how much sleep they get per school night, rounded to the nearest hour, and the results are presented in this frequency table. So you can see here, under 4 hours, there were two students that got 4 hours of sleep a night with a relative frequency of 4% and the cumulative relative frequency of 0.04. All right, so part A is to determine what is the five-number summary. Now, whenever you're asked to calculate the five-number summary, that's involving quartiles. And the best way to get that information is just to use your calculator. So I've got screenshots and instructions for using both the Texas Instruments and the NumWorks calculators for calculating these percentiles. So, kind of follow those two sets of instructions there to get the five-number summary. Let's move on to part B, where we need to calculate the 90th percentile. So since we're calculating the 90th percentile, then what we've got is that we've got a percentile rank of 9. Oh, sorry. One erase. There we go. K is equal to 90, and lowercase k is going to be 90 divided by 100, which is 0.90. So you want to look under the cumulative relative frequency and trying to find where 0.90 lives. And we can see in the table, and I've got a little bit of a screenshot here, that between 8 hours of sleep and 9 hours of sleep, we have a cumulative relative frequency of 0.8 and 0.94. So 0.90 would be right in between those two numbers. So 0.90 is between 0.8 and 0.94. Therefore, the 90th percentile will have to be a value of 9. There are 7 nines. One of them will be the datum whereby 90% of the rest of the datums are smaller than it, but one does not need to know exactly which 9. So this 80% means 80% of the datums in this data set are 8 hours and less, This 0.94 means 94% of the datums are 9 or less. So the fact that we've got a 90%, that's going to be one of these values of 9, because 90% is less than 94%, but above 80%. Okay, part C. So let's calculate the 80th percentile. So now this poses a problem. This is a case where the percentile rank equals the cumulative relative frequency of a datum. So if we come back up here, you can see here that because we're dealing with the 80th percentile, then this lowercase k value is going to be 0.80. And that's exactly the value that we have here for the cumulative relative frequency. But the problem is that this 80% means values 8 and less. But to calculate the kth percentile, we have to make sure that it's going to be a percent of datums that are strictly less than a value. So it can't be 8. So even though it's tempting to say that the 80th percentile is 8, it's not. So we have to go through this two-step process in order to calculate the 80th percentile. And this is the same process that we followed already. So to calculate the 80th percentile, that means the percentile rank is 80. And step one is to calculate the rank of our datum of interest, which is lowercase k times n plus 1. Lowercase k is going to be the percentile rank divided by 100, which will be 80 divided by 100, which will be 0.8. So the rank of 80 is going to be equal to 0.8 times 50 plus 1. And remember, we had 50 students in our data set. And when you simplify that expression, you get 40.8. And so 40 is the integer part, and 0.8 is the decimal part. So now we come to step 2 and bring our integer part and our decimal part with us. And because the decimal part is not equal to 0, we need to use this formula here. Let me get rid of some of that extra notation. Right? So the 80th percentile is going to be the 40th datum plus 0.8, that was our value of D, times the 41st datum minus the 40th datum. So off to the side here, I've got the 40th datum is 8 and the 41st datum is 9. Now, how did I know that? So we want to find the 40th number in the data set and the 41st number in the data set. So let's come up here. So here we've got frequency, but actually what's missing from here is going to be the cumulative frequency. So the cumulative frequency, if we were to make a separate column here, then to start this, we would start it with a value of 2. The cumulative frequency for 5 hours of sleep is going to be 5 plus 2, so it'll be 7. For 6 hours of sleep, it'll be 7 plus 7, which will be 14. The cumulative frequency for 7 hours of sleep will be 12 plus 14, which is 26. And then for 8 hours of sleep, it's going to be 14 plus 26, which is 40. And for 9 hours of sleep, it's going to be 7 plus 40, which will be 47. Okay, so we wanted to know what the 40th datum was. Well, the 40th datum will be an 8. So that's how I got 8 here. Okay, now what about the 41st datum? Well, if the 40th datum is 8, then the next one has to be a 9. That's how I got that the 41st datum is 9. So now I just substitute the 40th datum being 8 and the 41st datum being 9 into this formula, simplify, and I get the 80th percentile is 8.8 hours of sleep. Okay, now part D is going the other way around. So instead of given a rank, find the datum of interest, now we're given a percentile. Actually, we're given a datum of interest, and now we've got to figure out the percentile rank. So we want to calculate the percentile rank of 9. So here is 9 hours of sleep. And now we need to calculate what percentage of the datums are less than 9. So it might be tempting to choose k equals 80, okay, a percentile rank of 80. Since 80% of the datums are less than or equal to 8, in essence, 80% are strictly less than 9. And this is how the correct answer is determined in some textbooks and internet sources. But in this course, we want to stay consistent to the original definitions. So specifically, this is how we calculate the percentile rank of a datum of interest. Okay, so here we've got our formula for calculating percentile rank of our datum of interest. Our datum of interest is 9. The lowest rank of our datum of interest is 41. And our sample size is 50. So if we just substitute 41 for the rank of our datum of interest and 50 for n, okay, then we get this formula here. And 41 divided by 51 times 100 gives us 80.39. Always round that down, and we'll round it down to 80. So the percentile rank of 9 is 80. So in this case, deducing that the percentile rank of 9 would be 80 from the ungrouped frequency distribution table gave the same answer as using the equation that we just used. So we ended up calculating an percentile rank of 80, which is actually what we would have gotten if we had just looked at this table. But if you remember from a previous, what I talked about previously, this may not always be the case where the two will line up exactly. So stay consistent, use the formulas when you can, and then that'll ensure that you get the correct answer every time. Okay, let me know if you have any questions.